Hello everyone, welcome back. In the last video you were introduced to the idea of tensor products of maps. So there we explicitly saw that if A and B are 2 by 2 matrices, and then this is a 4 by 4 matrix, and this maps from V2 cross V2 to V2 cross V2 again, right? So a 2-qubit system, if you want to think physically. So now I want to work out an explicit example. Let's say that I have a psi in this state. Okay, it's not normalized. If you want to normalize it, you'll have a 1 by square root of 2 here and a 1 by square root of 2 here. But I don't want to write those 1 by square root of 2 factors every time. So let's just forget about normalization at this point. Okay, so this is the state, let's say. And what I want to do is that I want to act on this vector with this operator. I means I2. All right. So what will happen? So from the definition of tensor products, how it acts on the basis elements, you can easily calculate that A on psi will give you A on 0, the first bit, tensor identity on 0 plus A on 1 and identity on 1. All right. So now what you can see is that, okay, one more thing to notice here is that this state is an entangled state. All right, this state is an entangled state, and what you can see, you cannot write it as a tensor product of two vectors, and you cannot do it easily, so you have to calculate explicitly. Okay, so now what I'm trying to say is that how do I calculate A times 0? So let's say A is something like this: A, B, C, D. This is my A. Okay, so if this is A, what will be A times 0? You can easily check that this times 0, the 0 vector, would give you A and C, right? So you can write it as A times 0 plus C times 1. Similarly, you can calculate it by yourself that A times 1 should give you B times 0 plus D times 1. All right, now you can plug these results. Okay, let me mark it. You have this one and this one. Now you can plug these results here and here. Okay, so if you do that, if you plug that in, what you get is something like this. So you'll get A0 plus C1 tensor, and you had identity times 0, so you'll just get a 0, right? Plus you'll get B times 0 plus D1 tensor. You have identity times 1, which is just identity. All right, so which is just 1. Okay, so you just get this. And now if you do the multiplication again, you get A 0 0, because this tensor this will give you 0 0, plus C 1 0 plus B 0 1 plus D 1 1. Okay, so we started, so the final result is A times identity 2 on the vector 0 0 plus 1 1 would give you this result, A 0 0 plus C 1 0 plus B 0 1 plus D 1 1. All right, now I will give this to you as a quiz, that if I do the other way around, what I mean is that if I do identity cross A on this vector psi, what will be the answer? And I can give you a spoiler, that is, it will not be equal to A on psi. All right, so acting on the first qubit with identity and on the second qubit with A doesn't necessarily be equal to this equation, where you act on A on the first qubit and act on the qubit with identity in the second qubit. All right, so please try to work this example explicitly and check for yourself that these two ideas are different, but these will be useful in algorithms where you just have two qubit systems, say this state, and what you want to do is that you want to act on the first qubit only. All right, and you want to leave the second one as it is. This is how these operations are constructed. Once you understand gates and those things, then you will see that why these operations are really important. All right, till then, try to understand these things properly. Okay, thank you so much.